Yeah, so we've got quite a few going in the pipeline at the moment. One of the ones that I'm more heavily involved in is we've got a couple looking at machine learning. So we're engaging with other collaborators around the country, so the WA group through Jackie, but also the AIS group, to be able to create some bespoke apps but streamline some information for coaches. So for example, like we're working on a Javelin app project, which is looking at machine learning to create automated feedback for coaches around release angle, some key angular parameters, key release data, some stride data, which typically for us, that could take a couple of days to turn around. And that sort of limits sometimes the impact, whereas being able to create a bespoke app through machine learning means that we can have impact during a session, so a coach can be able to get automated feedback on some of that data and quantify what they're seeing, and also think about how they can have a bit more of immediate change. So sometimes they can see it but want confirmation that that's what is actually occurring and how that's all knitting together. We've also got 2 PhD students that are working with us to understand more of a strategic national approach to understanding talent identification in our elite athletes and metrics for performance success. So it's got some heavy biomech focuses, but also understanding the global impact of other disciplines as well and what makes up for some of our key athletes. So in Australia, we have probably a smaller pool of athletes to pull from compared to overseas. So it's how do we look at and target our resources towards that top end so that they can have big change, but also understanding what successful performance looks like on the global scale. So yeah, we've got a few ticking along in the background at the moment. We have been heavily involved in Olympic campaigns and Paralympic campaigns, but we're all now jumping back into progress and things to improve a lot of our practices. That's one of the key ones at the moment. So part of my role as lead is working with the network to look at what are we currently doing for our event groups? Does it target and support what the coaches and athletes needs are? How do we improve some of our practices? So new technologies are coming out. Machine learning is a big thing. So how can we also streamline and improve some of that? Like the work that's coming out of the UWA group and the work that they've done in the Jumps project is great. So we wouldn't be able to advance some of our practices without engaging with some of those collaborators. So yeah.
So the Pitch Ready sort of SaaS product very heavily relies on the biomechanical aspects. That's probably for me the core component of it. I reckon it's more about just informing the programming and
yeah, we did. We used Pitch Ready to assess a player's readiness to return from an ACL injury. Tim McGrath helped us with that. It was a fantastic tool. It gave us a good idea of, I guess, how the athlete was progressing, what her strengths were, and perhaps what her limitations were, and what things that we could really, I guess, focus on, particularly at that end stage where we were really fighting against time or the clock to try and get her back to give her an opportunity to be picked. So she made the last tournament and had the opportunity to play on, but in the end didn't get picked or selected for the Olympics, but did return to play. So that really helped at the end, both from a coaching tool and a feedback tool, but also helped us with our planning and I guess identified some areas where we needed to work on.
Yeah, excellent. I'm talking to Tim after you, so I'm keen to pick his brain about.
He was exceptional. Like, he was really, really good and a great way of thinking about it and breaking it down to us. Because I think the thing about biomechanics is there's so much out there, and I didn't touch on it before, but with speed stuff, like there's so many things that you could fix when you watch someone run and you think, there's so much you can fix. But I think the real detailing is being provided because ultimately they're footballers first and foremost, and then athletes. Obviously, athletic qualities underpin an enormous amount of their footballing ability in sevens, but I think what the good biomechanics does is teaches you what to harness in on and focus on, rather than having so many things to fix all the time. So that's probably the big thing for me is working out what to fix in what order, and then having a priority of things to do. So that's probably where the biomechanics really, I think, makes a big difference.
Yeah, so we've got some current projects looking at different footwear and sports bra designs. That's pretty much all I can say about that. And then other than that, still on the same, and most of our participant groups happen to be female athletes. We are interested mostly in looking at the movement of female athletes. Some of our other projects are around looking at the adaptability of female athletes in movement. And to be fair, that is an enormous task. So all of our projects spawn off of that idea, which is to look at our female athletes and how well they can adapt to various constraints we put into them. So obviously in sport, the name of the game is to put your participant in a position that they don't like to be in. But if you think about the way we look, particularly in biomechanics at human movement, we have this perspective of looking for the ideal, which is like the exact opposite of everything sport is about. So we've taken this approach, which is very challenging, I might add, of looking at everything but the ideal and how well someone can adapt to the not ideal. And that is our definition of athleticism. And so all of our projects around that are looking at different movement patterns, whether that's jumping, sidestepping, landing, all of these really key tasks that go across lots of sports that we've also used in the past as indicators of performance or injury risk. And we're looking at how well our female athletes adapt to various constraints we can put at them. And then from that, using that as either classifying them as potentially injurious or classifying them as highly adaptable, or what we would say is athletic.
Yeah, so we've done a fair bit of work with archery over the last few years, working primarily with a lot of their development athletes and helping the coaches, I guess, to provide good qualitative and quantitative feedback to some of these developing archers. So that's using a range of tools like high-speed video, 3D motion capture, and force plates. We've also done work with weightlifting, for example, again, doing something somewhat similar, providing quantitative information back to the coaches and athletes about weightlifting force application, particularly in the pull of the weightlift, first part of the weightlift. And then also working on sort of other projects like with our Centre of Excellence volleyball group, where we're looking to help them understand better the different demands that are placed on athletes when training on the sand versus on a court. So some of these questions, I guess, are quite specific to the sport. And again, it comes back to us being able to problem solve well for some of these difficult questions that are put in front of us and come up to a solution that's actually going to have some sort of positive impact on the sport. Outside of those sort of more sport-specific projects, we also constantly in the background are trying to iterate on our current processes and systems and make things more streamlined for the way, in particular, that we deal with data. So we do spend a fair bit of time in front of the computer coding and iterating on current pipeline structures we have, trying to make things easier for us down the track.
Let me just expand on for any students out there who might be new to biomechanics, what you mean by pipeline structures right at the end of your last answer there.
Yeah, so with a lot of different data types, particularly 3D motion capture, which we use extensively, you need some sort of back-end pipeline to take that data from its raw form through to something that's actually useful and I guess has the ability to impact on performance when we're talking about sports biomechanics. So being able to take that data from that initial form through to the end is what we would term our processing pipelines, and being able to speed that up and make that I guess as accurate and repeatable as possible, but also have a minimal amount of manual intervention is really important to us. So the faster we can we can do that, and the more efficient we can do that, the more time we can actually spend, hopefully having a positive impact with the sport.
In addition to the camps and the on-site sports that Dan's described that we work with on a more regular basis, we also do a range of background projects that allow us to improve our processes and speed up or increase our capability to kind of give feedback to coaches and athletes from a biomechanics perspective. Example of this is currently working on a IMU multi-segment model to allow us to improve the range of locations that we can do kind of kinematic assessment in.
So being in a service type role and in a lead management a little bit type role, sometimes it doesn't lead enough time to be able to look at emerging technologies and how we can put them into practice to be able to improve some of our practices as a biomech or an applied biomech in the field. So coding is a huge one at the moment. Machine learning is a big one. And being able to spend more time in that space, also in the inertial sensor technology space as well. I have done a little bit in it, and I'm very fortunate that I work with a really good colleague, Sarah Bryce, up at JCU, who's done a lot of work in that space. And, we often get questions from coaches that cameras are limited in what they can provide in the infield. So you have to spend a bit more time looking at what technologies are out there that can provide the answers to the coaches, but sometimes they provide more questions than answers at times. So in my role, I'd like to be able to spend a bit more time in that space to be able to deliver for coaches and athletes' needs, and evolving some of those practices and evolving my skill sets a little bit in that. But at the moment, it's been a little bit more time restrained than like, or lockdown restrained. So yeah, they're key things that I'm keen to jump into, but I also think will have a huge impact in where the future of our industry is going as well. And particularly being able to streamline practices, like I've seen a lot of the work that swimming have done through Jess Currens and Mark Elapo, and being able to look at the machine learning project and how that's had really positive impact on their processing and their feedback to coaches and athletes. So that's something that we're keen to explore in the athletic space as well. So yeah.
I think where there's two components to that is probably just the method that is derived. Like I find it quite interesting being someone who's not from the classic sort of pathway in there. I think the way that I sort of look at the data is probably slightly different to how people who come from more of a conventional method would treat it, where very much for them it's about waveform analysis and those sorts of things, is where for me it's really moments in time that I'm really sort of interested in, which is geared more towards the clinical aspect that I'm sort of chasing. So I find that really quite interesting. And then the other part is really just on the limitations of the technology. Like most of the return to play parts, we're trying to make it as close to the endpoint as in what they get exposed to when they actually sort of play. So really all we're limited to there is by the technology. I think as the technology improves and it just gets closer and closer to the actual endpoint, then I only see that as being a really, really good thing.
I think in strength and conditioning, or certainly in your university masters, I ended up doing two, but then in the PhD, I think is that what we touched upon is how do they apply that biomechanical knowledge or theory to coaching in everyday environment. And I think three-dimensional locomotive movement running is one of the hardest things to improve, as we said. But I think identifying that's what the really, really good coaches do. And so I think great coaches don't need biomechanics because they can see it with their eye, and then they can break it down, and they yes, they go back and they use the biomechanical video stuff to support them, but through their eye they're very good at it. And I think that's probably the next one, is being able to make it more tangible, particularly to, I guess, to a practical understanding, and how do you implement that, and then provide that implementation across different athletes, because you're going to have different movement challenges or different requirements and movement solutions within a group. So for me, that's the big one. I thought I knew a lot when I finished playing rugby, and then 5 years out, I thought, I actually don't know much at all. And now, as I get older and older, I'm realizing, my God, like, you know, so very little, in the industry, and you're working more and more in it. So I think that's the real one, and being able to have real life feedback, like real time data feedback. So be able to create apps or technology that allows you to break down that running mechanic in the moment and then bring it back. So that's hard, particularly in a cost-effective manner, and particularly when you might only have 10 or 15 minutes at the start of a session or within a session to coach speed, is how do you be able to give that feedback instantaneously to the athlete. That would be probably my thing of how the field probably still quite not at that level. For one-on-one stuff, it works really well, but obviously if you're in a team environment and you're doing big group training, how do you break that down to a granular level and provide them with that feedback?
Yeah, so this one both Dan and I were sort of debating before, and I guess one of the elements of this one is that I kind of love to know, or be able to remember, a lot of what we kind of already learned. It's kind of one of the aspects of our role is being quite general across a range of different applications. So being quite specific and having that detailed knowledge in one really specific area is not always possible, but being able to remember, what you learn at university or wherever it was like that you did would be highly valuable. So having the time to be an expert in something would be fantastic, but just generally, a broad knowledge is kind of helpful. But I'd love to know that detailed knowledge across all the areas.